Hey, Alyssa, how you doing?
Hi, Joe. Doing great. How are you?
Great, great. It's good to have you on. So we have Alessya Visnjic from YLabs with the Data Nerd Herd today. So I guess for people who don't know who you are, do you want to tell people about yourself?
Absolutely. Would love to. My name is Alyssa. I'm the CEO and co-founder of a startup called YLabs. We're on a mission to build a layer between AI and human stakeholders or operators. And what that really means is we're building an observability platform that enables anybody who is operating an AI application in an enterprise to monitor, alert on data quality, data drift changes, to watch performance, and to send retraining triggers or other triggers to the pipeline based on what's happening with the data that runs through the pipeline.
That's really cool. Yeah, and this is a big space and a fairly new space. I mean, what got you into I guess if we ran back, like how did you get into data in the first place, and kind of what brought you to what you're doing with YLabs today?
Sure. So my career started at Amazon, and I've spent almost 10 years there. And interestingly enough, my kind of time at Amazon was split into two groups. The first 5 years I spent in the DevOps world. So I worked uh, at a group called Platform Excellence that basically is responsible for making sure that the retail website is available fast, doesn't have fatals. So very operational team looking out for the infrastructure and latency. So there I grew, my appreciation for what does it look like to operate a piece of technology like the Amazon retail website, global retail website. What does the DevOps world look like? How is it growing? How is it developing? And what's the state of art in the DevOps tooling? And then halfway through, when machine learning started becoming sexy again, Amazon started building R&D groups that would essentially be responsible for deploying machine learning solutions internally in the company. And I switched over to join one of those groups in Berlin, Germany. And there I was effectively the bridge between research, engineering and the business. And in that capacity, I had the pleasure of launching a lot of machine learning applications to production. And because of my DevOps background, I would always be eager to grab the pager and be on call for what we're launching. So one example is we launched a demand forecasting pipeline that was forecasting for a quarter of all Amazon SKUs. And I was on call for that for the first month or so, pretty much solely. And as part of that experience, I really got to learn what it's like to operate a machine learning application, large scale machine learning application, how they fail, how different are the failures from what we expect in the traditional software. And we were building tools as we're flying, essentially. So, really, essentially, developed an appreciation for what the ecosystem could be like if it would grow into a full, what we call now ML Ops ecosystem. This was back in 2013, 2014, so ML Ops wasn't a thing. But we were just building tools to help us survive the on call and to deliver the best customer experience to the end users that were using the machine learning applications.
That's amazing. I think you're probably one of the first ML ops engineers, probably by default. So, I mean, that's really
By
cool, though, that
default.
you got to basically, it seemed like you had to kind of figure this out as you went along. Like there wasn't really a playbook on how to do this back then.
Yeah, pretty much. We were using a lot of the patterns from kind of DevOps best practices, so reproducibility, versioning, unit testing. But as you know, these things don't translate well into the data world from the DevOps world. So there was a lot of essentially reinvention of how this would work if data is a big factor, if data can change the behavior of your system. And that's where I kind of started looking into this whole space of emerging tooling, um, building some patterns out. Eventually, the tools that we built at Amazon were consolidated into what we call an internal machine learning platform, which I co founded with a few of my colleagues from that time. And that was one of the first kind of manifestations of what we call now the MLOps ecosystem at Amazon.
Interesting. I mean, as a user of AWS, I mean, how much of your work influenced what you see on the AWS side? Are they similar? Can you say much about that? Or
Yeah, a lot of the work we were doing internally for internal machine learning applications was then consolidated into SageMaker. So now a lot of the things that we were building and kind of treating as dog food for the future SageMaker pieces is now part of SageMaker. So like things like forecast, AWS forecasting, if you've heard of it, have used it, was largely influenced by that forecasting project, and it has a lot of kind of MLOps features built into it. And then SageMaker, of course, has versioning, reproducible notebooks, infrastructure that can be spun up from just a user interface, flexible infrastructure configurations, things like that. So all of that was later consolidated into SageMaker.
that's amazing. I mean, what walk me through the early days of that. I'm intrigued because I mean, it sounds like you're basically having to take whatever kind of appropriate whatever best practices you could find from different fields. I mean, what was the process of trying to figure this out in real time, especially as you had like a forecasting system that was running a pretty substantial amount of SKUs on Amazon?
Yeah, well, I think the first challenge that we had to tackle is reproducibility, because when something inevitably fails, and when you're building a system of this scale and you're building something that hasn't been built before, we were working on essentially a really large scale demand forecasting, so time series forecasting system, and it was really complex and really large scale. So a quarter of all Amazon SKUs were generating a demand forecast for each SKU, and there are about 10 million in each of the geographical locations, and the demand forecast is generated for 365 days. So we're generating 365 data points into the future. And we had to generate a distribution. So we were generating samples, 100 samples, 365 days for 10 million SKUs. So when that process, for whatever reason, fails, what you need to do as quickly as possible is, figure out how to warm start it if you can, and figure out how to reproduce it, and understand how to fix what failed. So that was the first challenge that we were facing. And I think from kind of the patterns perspective, design patterns in software engineering world, we do have a concept of multiple environments. We do have a concept of tracing, logging. We do have a concept of spinning up a local version of the software. These are all table stakes in traditional software. With the machine learning world, well, to this day, sometimes I talk to customers who do not persist the state of the system, do not persist the data that went into training because they just stream it, do not persist the data that goes through inference. So reproducibility, I think, is still a big challenge to this day. And it is, at Amazon, we were solving it in a case-by-case basis. And that was one of the first things to tackle.
That's insane. I mean, my impression of this is like basically ML ops, especially right now. It reminds me a lot of where software engineering was actually back. Maybe kind of when DevOps was coming into vogue. I don't know if my perception is accurate or matches what you're seeing out there, but it seems like I wouldn't say ML ops is a field, but I would say the practices people are adopting in machine learning right now reminds me a lot of how software was back before there were more rigid practices. So.
Yeah, I would agree. And it's fascinating to watch this field develop because a lot of the people who are involved, data scientists, machine learning scientists, machine learning engineers, they didn't typically go through the path of being in traditional software and being in the DevOps world and watching this DevOps world come together. So there's a lot of rediscovery that's happening. There's a lot of reinvention that's happening. It's interesting to watch this field kind of boom. The ecosystem is exploding. I mean, there is a spreadsheet that I've seen in the MLOps community Slack channel that tracks over 350 different MLOps tools. And I believe that's just the top of the iceberg.
Yeah, I would think so. Because it's yeah, it doesn't account for like the things that nobody's really seen out there. And I guarantee. I mean, I know personally people that have worked on like MLOpsy stuff. It's not being used by anyone. But yeah, that's interesting. I mean, the question I typically have too is like, what would happen to data science if we just kind of continued without MLOps?
Well, I don't have an answer, but I have a
Yeah,
few anecdotes.
sure.
So when in the very beginning of YLabs, essentially my history is I left Amazon with the goal of figuring out how to do what we've been doing at Amazon for Amazon, but for essentially everybody, because it became very clear that every enterprise that is deploying machine learning to production, given that AWS is successful at democratizing, the tools to get machine learning applications to production. Once they're in production, enterprises are going to need these tools. And what do these tools look like? It was unclear. I mean, we have a sense. I have a sense of what they look like at Amazon. We have a sense of what they look like at LinkedIn, at Airbnb, at Uber, etc. So because each one of these organizations have built their own ML ops stack essentially. But what do they look like in the generic way? Like what's the data dog for machine learning applications? It's not clear. So I left Amazon with the goal of trying to figure that out. I went to spend time at the Allen Institute for AI here in Seattle. It's a fundamental AI research institute where I was fortunate to be surrounded by some of the best minds in AI. And the question I was asking them is, what does it look like to operate these systems at scale with this type of rigor? So a lot of discussions and brainstorming sessions going to first principles of how to design these tools. And then I had the fortune of being in Seattle, pre-COVID days. There are 180 plus data science outposts here in Seattle. So I spent time talking to a lot of data scientists across these organizations over coffee. I could drink a lot of coffee. So the question I would ask them is, do you have something running in production? Tell me what it's like. What is your day like? What's frustrating? What do you think your best practices are? And oftentimes, I would say 9 out of 10, there's at least one story of how things fail. And the stories was typically something that happened recently in the last month or two. And they're about, all of the classic failures of machine learning applications that are driven by things as simple as data quality, data drift, something being reconfigured and not persisted, infrastructure not being configured correctly, code not being pushed correctly. So those were the stories of what happens with machine learning systems when there's no DevOps. And I think that's still happening every day. I bet there are teams that are fully data science teams that are embracing the concept of on-call nowadays to operate these systems, because if you don't have the right tools, then you basically do it manually. And I think that's our world today, the world without MLOps, given that MLOps is something that's still developing and kind of figuring out what the ecosystem would be like.
Hmm. Yeah, it reminds me of something one of my friends says where for the longest time, machine learning, I would say in the broader world, maybe not at the top tech companies, but the broader world, it's been like somebody's learning to play the piano and they just play like the first four bars of the song and they just keep repeating that over and over and don't bother with the rest of it. And that's kind of, what I think that refers to is the attention has really been on building models, right, and training models and all this other stuff. But that seems to be much more of a solved problem these days than it was even, a few years ago. And now, the attention is definitely on, okay, so how are we going to productionize this stuff? I think it's interesting because you and your colleagues have been, like, I would say, years ahead of where the rest of the the attention has been focused, and it's um, so I mean I think it's interesting because now MLOps is suddenly this hot thing, whereas people like yourself have been basically like kind of inventing it for a bit. So yeah.
Absolutely. I think this it's a logical development of what happens once the step of I would say what 5 6 years ago everybody was talking about defining what machine learning is in the organization, what's the value of it, how to hire data scientists, how to hire ML engineers. Or I guess even 6 years ago, we didn't even have a concept of an ML engineer. We just had data scientists and ML scientists. So organizations didn't have anything running in production, and all they were trying to figure out is how to build models. I think that problem is largely solved, although it's still I think it's a little too early to call it solved, because if you look at the kind of stacks of these machine learning applications, every single one is its own snowflake. There's for certain classes of models, there's an easy choice between, let's say, PyTorch and TensorFlow. For linear models, there's a whole array of different frameworks. Then everything gets more complicated with the introduction of where the data is coming from and how do you orchestrate everything, how do things talk to each other, et cetera, et cetera. So every system that you see implemented, like production grade system, looks nothing like any other one that you've seen before. And I think that's a sign of we know how to get there. So with n number of engineers and data scientists given n number of days, they will build something that would run at scale and will be reproducible and will be reliable. But there's still a large element of invention and research of how to put these Lego blocks together. And frankly, there's so many different Lego blocks now that it's just choosing which ones to go with is already quite an endeavor.
What's your recommendation for companies that are interested in getting started in MLOps? Like, if you were to maybe establish sort of a blueprint, what would you recommend?
Ooh. It really depends on the type of problem at hand, right, and the scale of the problem. I think in many cases, well, it's hard to answer this question simply because for, let's say, like a batch system, for a batch type of problem that doesn't use a ton of data, maybe you go with something very straightforward and not over engineer it. For something that requires streaming, low latency, you would use something totally different, right? I would say the general shape of that system should have consistency in where's the data coming from, what's happening to the data. So oftentimes, I guess reproducibility is a theme. So do you do data transformations in some unversioned Jupyter notebook? Oh, that's an anti-pattern. Do you have a good sense of what happens to the data while it stays in the data store? Let's say you have even a database, what's happening to the data there? What are the data providers? Are they reliable? Is the data fresh? Can you rely on the data quality? Do you know when things happen that hinder data quality? Essentially, do you have a way of reproducing and watching the data store? Do you have a way of reproducing and watching what's happening at feature transformation level? Do you have a way of reproducing and monitoring what's happening at training and so on? I think any of those Lego blocks that are available right now are very good Lego blocks. There are systems that are running at scale that are built out of, on top of GCP plus TensorFlow plus, there's maybe MLflow that's orchestrating things, and they're working perfectly well, but that system might not work for a different set of use cases. And it's all about reproducibility and a way to essentially catch issues when they happen, and being able to dive deep and debug them, being able to understand and trace at which point things started going south. I wish I had a better answer, but
No, I think it's a good answer though, and in part it does kind of show, uh, in a sense, that, it is early days in ML ops, right? I mean, there isn't like the gold standard yet, and but I think you're hitting on something with the reproducibility aspect that's pretty central. I mean, I'm sure as you talk to companies out there, you're seeing sort of firsthand what workflows people are using and so forth. I mean, what are there some common themes that you're seeing with, uh, I guess, people's attempts at ML ops so far? Um,
well, tell me what you mean by that.
yeah, so I mean, are you seeing as you? I'm talking about like non established tech companies. So you're not your Ubers, not your Netflixes, not your Amazons. But if you go out into um, you know uh, middle America, so to speak, talk to people who are doing machine learning. Are there commonalities in terms of how they're trying to, I guess, attain reproducibility in their models, or are they doing it at all, or what are some of the design patterns that you might be seeing out there, or conversely, I guess, lack of design patterns?
I, I think the only design pattern, which is an anti-pattern that is definitely there, is Jupyter notebooks are used very heavily for things that they probably shouldn't be used for. But for those who are running, production grade pipelines, that I think you get to production grade pipelines when you have scale and frequency, right? So if we're talking about pipelines that run a batch every month, it it's probably some kind of cron job that is not monitored, that somebody kicks off by hand. And unfortunately, that's just the way the world is right now. uh, and it could be perfectly fine. I think a lot of the BI systems that I see, that's how they're structured. There's some kind of cron job that goes in and gets data from some kind of database. There's some transformations happening, very simple scikit-learn setup is there to train the model, and then things get scored, and then they're persisted again to some kind of database, and that's a perfectly good pattern if it's a batch system that is kicked off once a month. Maybe there's no necessity to make it more sophisticated. I think what's missing in such system is an ability to monitor and troubleshoot when things don't work well, even for that short batch. Um, because if you are generating predictions, there's trust downstream in the business in those predictions. And if for some reason there is inconsistencies between what the business expected and what the predictions are, you need to be able to go and troubleshoot that and figure out which way the inconsistencies are coming from.
Makes a lot of sense.
So there are systems as simple as that, but then we have MLflow that I think is really well adopted for kind of gluing things all together. We have data stores that show up very commonly, whether it's AWS's data stores or GCP's data stores, and then very common ML frameworks. I would say for anything deep learning, obviously it's TensorFlow, PyTorch. For boosted trees, XGBoost. For linear models, scikit-learn. Those are typically the systems for kind of the works, the table stakes of modeling tasks that people are solving.
Yeah, definitely. Um, and onto your company YLabs. I mean, you mentioned there's 350 MLOps projects out there, and it's a lot of variation, a lot of choices. A lot of smart people working on various aspects of MLOps. Like, what got you interested in solving the types of problems that you're solving at YLabs?
I think, well, what got me interested in that is this confluence of my DevOps experience and machine learning experience, and specifically what we're doing at YLabs is enabling what we say observability by the way of monitoring, enabling logging in the pipeline, and so on. And I think that's a very interesting and a very hard problem to solve. It's not as kind of infrastructure specific as some of the orchestration ML ops projects out there. It touches the data, it touches the model. It it's so monitoring and observability. The way I look at it is it sits kind of in the middle, where a lot of interesting machine learning research endeavors overlap. Things like model evaluation, monitoring, training, inference skew, explainability, catching adversarial attacks. Enabling that observability essentially would enable then to create ways of explaining the predictions, create ways of testing the models, create ways of identifying distribution drifts, create ways of identifying whether more data needs to be labeled, and so on. So the fact that it sits there in the middle is really intriguing to me, because it allows us to not just solve the problem at hand right now, which is monitoring for data quality and data drift. I think that's the biggest pain point, but also have a vision where we touch things like explainability, adversarial attacks, fairness, and so on.
Yeah, that's quite a bit. The interesting thing with the data quality and data drift, if you don't mind talking more about that, like why do you see that as one of the bigger problems out there right now?
I think, well, why? That's a good question. Statistically, it's definitely the biggest problem. When you ask machine learning engineers and data scientists who are operating these models, what are their biggest pain points? Typically, it starts with um, expectations not met once the model is deployed to production, and it's either immediately, so the model was evaluated offline and then it was deployed, and once the actual start to show up, they noticed that, okay, the accuracy is not what we expected, or the model is failing in the eyes of the customer. So what the predictions that the customers are getting, are not resonating with the customer, and then the customer complains. Those are like the two most common failure modes. And kind of the low-hanging fruit of identifying what causes these failure modes, I mean, I think starts with data quality, because the training and inference skew starts essentially what we can say with data drift, but data drift is more or less like a subsection of data quality, right? Of data statistics. So enabling data quality monitoring in the system is the easiest thing you can do, starting to monitor for missing values, starting to monitor for distributions, monitoring for data types, because we're working with languages that are not strongly typed, so things can go south again without us even noticing, without us even changing code, but changing the data. So those are the simple things that could be solved, and those are the first things that people try to address in semi-automatic manner. So imagine you're on call and you notice that, okay, my model is not behaving correctly because upstream the whatever data contract agreement we had is not strictly enforced. So all of a sudden I get missing values for this feature, and the actual feature values are in some other feature, and there are duplicates in the data that I'm getting, or there are a ton of missing values all over the place, and the model accuracy is affected. That's the first thing that you would want to go and figure out how to semi-automate checking for, so you're not woken up in the middle of the night when you're on call for this. That's why I think data quality perhaps is one of the first things that's top of mind right now for engineers.
Mm-hmm. Yeah, I definitely can empathize with that. Having experienced countless data quality blowups in my career.
What's your experience? I'd love to.
Yeah, I mean, this happens a lot. I would say, okay, so business data, for example, right? I'm not talking about unstructured data like images or whatever. Like human-generated data is usually typed into an ERP system or, God forbid, an Excel sheet, which happens a lot, and that's somehow translated into a system maybe that's imported into an ERP. Inevitably, those systems have issues. So your business source systems, whatever they are, it could be an order system even, right? Typos happen. Um, and what I notice is there's not really like a master data management, for example, right? So checking records to make sure they're valid before they're saved to a database, huge issue.
Mm-hmm.
And then there's not a lot you can really do about that if you haven't kind of either if you're not checking it, for example, or more more to the point, working with engineering to fix the root cause of the issue. But this happens, I would say, in every business I've seen. I don't think it hasn't happened yet. So, I mean, my wish for the world is like that problem gets fixed, but that's pretty big goal. So, but it reflects though, I think it downstream into the stuff that you're exactly talking about, right? Data quality, it affects everything. It affects everything from reports to model building to kind of everything in between. And yeah.
I think you're bringing up an interesting point. I call data quality, the low hanging fruit of our problems. But what you're saying is in BI systems, this problem is still there, and BI systems have existed for a very long time, which makes me wonder, why haven't well has this problem been addressed to a degree by companies like Informatica, for example, which does data quality monitoring or data quality checking for kind of BI human generated data stores.
Mm-hmm.
And if it hasn't been addressed yet, why hasn't it? That's
I think
something for us to ponder on, I
my
think.
my impression of this is a lot of companies, and again, I'm talking about what I call dark matter companies, right? So these are like companies that comprise like 95% of the known universe of companies. You'll never hear about them. They employ most people, highly profitable. They're probably running an on-prem Windows system, to be frank. Like they're barely in the cloud. And so the level of, I wouldn't even call it a sophistication question as much as I would just say they don't even know that this is a problem, right? And so when you get into these companies, the habits are, well, the direction of the report's correct, right? And so when you start hearing that, that's like a huge symptom that your data it needs some work. So so when you hear, oh well, the trend is consistent, even though the numbers might be like completely off, like that's a big red flag, and that is unfortunately, at least in my experience, like I kind of deal with almost the opposite types of companies as maybe you might, where it's like our business is mainly these dark matter companies. Some big names thrown in there, but in a lot of cases, I would say even the bigger companies have a lot of the same issues because the data literacy isn't. If you go back to the root cause of the organization, right? Like data literacy isn't really emphasized very much. It's like just do your job, make your reports, try and make money for us, and that's it. So I think it's as much of a technology issue as it is a cultural issue, where if data quality isn't emphasized and accuracy isn't like kind of beat into people's heads, like they won't care. And if you don't care, if you bring a data quality tool and people just say, well, that's just going to make my job more difficult actually, so I'm just going to not do that, right? Because now I have to do extra work and I just want to clock out at 5 and go home. So I think it's as much of a technology issue as and I noticed maybe even more really, because my impression is with data, if you kind of, no pun intended, do like 5 whys on like a data issue,
Mm-hmm.
it inevitably comes back to an organization issue time and time again. It's like we simply don't want to invest the willpower into like fixing this problem that we may or may not know exists, and we're making money, so why does it matter, right? Like unfortunately, this is just kind of the psychology that at least I've noticed, and so.
Interesting. I think what's I wonder if this is driven by I guess the hype wave some number of years ago, probably 10 years ago now, of like being data driven.
Mm-hmm.
So it was, very sexy to say that you're a data driven company and that you make decisions based on the data, which basically means that you have somebody who's crunching this report, then you're looking at this report, and if it reinforces what you already thought is happening, then you say, yay, we're data driven, we're doing
Right.
exactly what this data is saying. And if the report disagrees with you, then you probably just ignore the report because,
Hmm.
who knows, what does this report know?
Right.
And now this is kind of built into the culture of how this data is being used for making decisions.
Hmm.
And I wonder if one of the biggest challenges in changing this culture is figuring out uh, how to measure the fact that if you're using bad data to make decisions, this is what your losses are going to be like. Or if you're maybe employing data engineers, but not really using the information they're giving you to make decisions, then those are essentially your losses.
Hmm.
I don't think enough is being talked on this subject, and I don't think many people are spending time in the space. I think, back to our conversation of 300 plus ML tools, ML ops tools, all of them are focused on ML. Very few look at data first, and then ML is just down the pipeline from
Right.
where the data lives.
Uh-huh. Yeah, because in a lot of cases, like, you talked about data driven being kind of the vogue thing 10 years ago, and it definitely is still, um, I think top of mind with a lot of CIOs or CTOs, right? And I would say also around 2015 when ML started coming into vogue, now the impression is, oh, well, we got to start doing that too. So let's just start doing that without really a recognition that, yeah, our data probably isn't that good to make models off of, but let's just make models and just see what happens. I mean, I've seen this happen countless times. Uh, my experience is more like automated machine learning, so AutoML. So I was doing that, and people just come to us with the structured data and import it in and just expect magical stuff to happen. And I was like, yeah, I think I see a common problem here. So, like, your source data is just it's not really usable. But I think there's also a lot of FOMO, right, in this, where it's kind of like, if we're not doing ML, then obviously our competitors are going to do it, and so it's interesting. But when you look at the, again, when I don't know about you, but when I would ask questions about, okay, so why is the data in this state, it inevitably came back to like practices within the organization around data. So.
It all goes back to culture in the company, and culture of
Mhm.
us as a discipline, as a data discipline professionals.
But DevOps, I think, did a really good job at least as a movement in terms of adopting, or at least recognizing, culture and human practices as essential to making DevOps work. I don't know what your thoughts on that are, but.
Yeah, this I think this brings up an interesting point of community being a huge, I would say, forcing function around how DevOps developed. Like looking back at I don't know, movements like uh, I think like Chef, for example, is a great
Mhm.
example. Had a huge community built around how they were solving the problems, and in general, there were a number of conferences where people were, trying to come together and solve DevOps problems as a community. I think in the ML Ops world, this is just beginning. So I think ML Ops community is a great example of that coming together. There's a lot of kind of thinking, group discussion, brainstorming. Where are we going? How do we change this culture? But from the discussion we just had a minute ago, it sounds like we're essentially skipping a stage. So we're going from DevOps to ML ops, and there's data, you know, data literacy, data hygiene that's sitting in the middle. And if we just skip that and go to build tools just for the companies who are way ahead, and maybe in the way they treat data and how they think about culturally about the data that their company is generating and using for machine learning and BI, they've already kind of advanced that culture, but there's still, as you say, 90% of the companies that names of which we don't even know, that are kind of stuck in this phase. And I do wish, and now that we're discussing, I wonder how I can be more proactive in those communities
Hmm.
and see what we can do as again the ML Ops community, since that has quite some momentum. What can we do to talk about the tools and about the processes in the company that would enable better data hygiene in companies that maybe are not even doing machine learning? They're just thinking
Hmm.
about working with their data.
Yeah, yeah, I completely agree. It is. I mean, I think about this a lot too. Like, talking to CTOs, CIOs of these companies, really getting them make just trying to get the wheels turning, right? I mean, these are obviously smart people. I think it's in a lot of cases maybe they don't know the questions to ask. Um, I know that's a lot of what my company does. We just help companies evaluate the right tools and then show them how to use them. And there's, I mean, it's interesting. I mean, even discussions around like moving to cloud right now. That's still a question for a lot of companies. And cloud's been around for a long time now, or well,
Yeah.
not like a bajillion years, but relatively speaking. But when you look, but when you take a step back though, right, and look at the number of companies in the cloud, I think depending on who you want to believe, it's like cloud footprint's only maybe 25%,
Mm-hmm.
of total IT infrastructure. So I mean, there's still a long ways to go there, right? And it's sort of this supposition, because when people like you and I talk with each other, it's kind of like we're assuming, oh, everyone's in the cloud at this point, and like, everyone's doing AI, it's fine. They're just, but if you zoom out, it's kind of crazy just how much potential and opportunity there still is in this space. But a lot of it, I think it's going to come down to just educating the CIOs and the CTOs of a lot of these companies, and the CEOs too. Like they'll read an article in Forbes about AI and think, oh well, we got to hop on that, and let's move to the cloud while we're at it too. And like, uh, it's so the maturity I think is still underway. Is what I'm trying to get at, right? So
And so to make us all feel better about the maturity of data and ML operations, I would say looking at the DevOps world,
yep.
it's still booming, right? I would say one of the cool efforts that I'm watching right now is open telemetry, and that has been around only for a few years. And companies like Datadog and New Relic and Sumo Logic and Honeycomb, and to name just 4 out of 20 something companies in that space. They've been around for a long time. They solved problems for a majority of Fortune 500 organizations. But the standard way of thinking about telemetry, which is in the heart of essentially all of the DevOps, the culture of how this telemetry is, how do these standards come together? Is it community decided? So in case of open telemetry, it is community kind of driven. All of this just started happening recently. So I
That's
think
cool.
we are just fortunate to be in the very early days of seeing. I would maybe even drop the whole ML from this and say we are in the very early days of seeing how data could be used to help make decisions in
Hmm.
organizations, and we have a long way to go.
Yeah, but it's a great opportunity. I mean,
Absolutely.
we both work in the data space for. I think it's not an accident. Like we didn't like say, oh, data seems kind of fun. I'll be in that one.
It's
I mean, it is fun, but there's a lot of opportunity, right? You kind of fish where the fish are, as the saying goes. So
absolutely. And I mean, I think opportunity, one, innovation, like all of these problems that we're discussing, some of them are process problems, culture problems, many of them are engineering problems, and
mhm.
all of these problems are not solved. So I do hope that, kind of thinking back to what my computer science and math education was like many years ago. I mean, even DevOps wasn't a thing that I learned in college. culture of, well, I mean, I learned statistics because I have an applied math degree,
Hmm.
but I would say statistics is not something that is taught in computer science department. Many computer science graduates don't even go through a statistics course. So when they do graduate and then they go into companies that pride themselves of being data driven, uh, perhaps they don't have the right background to really understand that in order to be data driven, you need to have a culture of trusting your data, and in order to trust your data, you need to make sure that your data is reliable, high quality, uh, and so on.
Hmm. Yeah. Yeah, it is early days. I mean, it's interesting because I think when you're in the middle of it, it feels like, like, oh, we're definitely like going to solve this problem for real. And then I think, it's interesting because I always do the thought experiment. So in 10 years, will I feel the same way? I don't know about you, but the more I look out, try and zoom out, I'm just like, wow, there's a ton of potential. And yeah, it does feel like it's just, we're all just kind of getting started. So,
Well, I would say 2014.
uh-huh.
2014, my team was working on one of the first large scale Spark deployments at Amazon.
Wow.
And that felt really exciting. And a lot of things were really hard to get working. It was a big project. It was a joy to watch it work once we got it working. It was not a joy to move to Spark 2.0 later, but that's a different story. Now, 2014 to now, it's been 7 years, let's say roughly, and we're talking about Spark 3.0. Spark deployments are still hard. Building large scale data pipelines is still hard.
Hmm.
I think 10 years from now, we're probably going to see a lot of similar problems. They will
Hmm.
likely be of a different scale. I think that one thing that changes uh, pretty reliably is the scale of
Hmm.
things that we talk about. So we get more data, and we're just generating more data as a society, and then we want things faster because as a society we're just expecting things to happen faster. Thanks Amazon for Prime Now. So I think the things that definitely will change is amounts of data and how fast we expect things to happen, but probably many of the problems are still going to be there, which is
Yeah.
awesome. I mean, it's great. I'm excited to be in this for probably the rest of my career. There are enough
Same.
problems to be solved there, and I think it's actually amazing to say at this point of our careers that we did find something that we could be excited about for the next 10, 20 years, and actually hopefully make a difference in the space for.
Yeah. Yeah. For sure. I mean, I was just reading today about Google's new AI model that was like 1.3 trillion parameters or something crazy like that. And GPT-3, like, I mean, what did they announce? Like 30 billion or something like that parameters. It's crazy just the scale of things are growing. But when you kind of zoom out and you look back, it's like, that's probably going to seem really quaint in a few years when, you're talking.
The curve is yes.
Mhm. Yeah, it's insane. So I mean, what are your thoughts too? I mean, so on one hand you have these like giant models being made, and on the other hand, like edge ML and federated learning is becoming and more of a thing. I guess kind of where do you see the landscape, especially with respect to ML ops, on the I guess the edge computing end of things?
Oh, I mean, I think that's one of the most exciting places for us to watch. And that actually going back to what I just said about volumes of data and kind of speed expectations is the place where all of these things are kind of converging, right? So we're talking about deploying models, well, in case of federated learning, on cell phones, and the data that's being produced by cell phone is pretty incredible. I mean, just like tracking location, right, for one cell phone user. Uh, Actually, the famous example of federated learning deployment is predicting a kind of autocorrect for the user. So essentially, the model is trained on everything that you type, and I type a lot on my cell phone. I think I type on my cell phone more than I type on my laptop. with exception if I'm writing like a blog post.
Hmm.
So, data volumes are large. There are big privacy concerns. We don't want to ship all that data around. We definitely don't want to take all the data from the cell phone and ship it to some centralized place because, well, A, privacy, and B, it's just really expensive, right? And then, of course, the instant gratification angle. We want results really fast. These models have to be really fast and they have to be pretty accurate. I would say now we're a generation that expects, well, we have a generation that expects computers to be smart. I think like if I look at my grandma, she doesn't expect the computer to be smart. Like when the computer doesn't do what she expects, she's like, okay, well, that's just a computer. What can it expect? When I look at teenagers, they expect the computer to be smart and reliable and do exactly what like they think about it, and they already expect it to do it. So I think all of these things are moving this whole edge world, and are powering, innovation and the development of various methods that would survive in the edge world, which is, how fast can we process, how light can we be on compute, how can we process things locally, etc. So I think that's where a lot of the boundaries of what's currently possible with machine learning are going to be pushed, and a lot of boundaries of what's currently possible with ML ops are going to be pushed.
Oh yeah, yeah. I mean, I think it last night too. I was watching my two boys playing. Have you heard of Among Us, the game?
No, I haven't.
Yeah, me neither. Until like my 7 and 10 year old basically have downloaded every copy of it on like every device, and they're calling up their friend. She's playing it on her parents' phone. So it was just a funny scene where these two kids are in their bunk bed playing Among Us with their friend and talking on the another phone over here with their friend. It was just it's just how it is. But meanwhile, all this data is being collected about these kids. So
That is
it's pretty
another
crazy.
scary thing that's happening, right?
Yeah, it's like it just makes, I guess, because it's on our phones, right? The parents' phones, it makes it look like the parents are just geeking out among us. But still, it's
I'm
interesting.
sure
They figure it out.
there's already a way to very. I mean, the fun things, and I think that's where the some of the differential privacy research was what was pushed to its boundaries, where we were under the assumption that personally identifiable data is things that we invented, like social security numbers and credit cards and so on. But it turns out that the way you hold your phone and the way you type is unique to you and can identify you personally. So I'm pretty sure that it's
Yeah.
very easy to tell when it's your kids versus you using the phone.
Hmm. Yeah. Yeah. Fun to think about. So,
But I think that's another really scary subject. that
yeah, yeah. I mean that's I think that's going to be the battle, especially for even our kids' generation too. Is just the use of data, especially when if you think about the implications of it when you're a kid, basically like using all these devices as a minor, right? Like that's going to have some interesting implications that not sure how that's used yet, but it's
seems like culture is a big theme of our conversation today. And I think what's interesting is culturally, let's say our generation has a lot of um, doubts and I guess distrust about what's happening to our data, what data is being collected, who has it, what do they do with it. Working with a few interns for the past few years, I would say, even the generation that's graduating from the university right now, to them, they don't think of their data as being their data. Like they don't feel ownership of it. They are very used to the fact that everything is being tracked, that things are being recorded. I mean, they're in before they could even make decisions, their parents were posting their pictures on Facebook. So that's the generation already that's graduating from universities. Uh, so for them, there's no inherent assumption that it's that the data that they generate is their data, so they don't feel as protective of it. And it's actually really fascinating talking to them about how do they feel that all of this is being tracked and recorded, and to them, it's just something they're completely used to. So I wonder how that sentiment is going to change, the way we think about these technologies being part of our life.
I'm sure it's going to change quite a bit because it's all context, right? Like, you know, one culture, one country's version of what's good to use for data. I'm thinking of places in Asia, for example, versus here. It's a different universe. Like I was trying to describe to my kids, I grew up in the '80s when, I said, to him the other day, I was like, I think I'm one of the last generation where I remember life before the internet, right? And then I remember obviously life after the internet, and it's a much different world. And yeah, you're right. It's a total cultural thing, and I guess whatever they feel is the ethical way to use data at that point, I have no idea what that's going to look like, but time will tell, I guess. And that'll be an interesting space for ML apps as well, right? I think the ethical considerations, that stuff that we haven't even thought of yet. It's not even like the Vogue conversations. Like that's going to be pretty big. So.
I think so. As you were describing, kind of the how data privacy is respected in different parts of the world. One thing I was thinking is, or one thing that came to my mind immediately, rather, is that the big reason to work on ML ops and the big reason to not just start changing the culture of how people think about data in organizations and enterprises, but also how people use data, how they make decisions on this data is the ethical component. Because it's one thing to use data that has data quality problems and make a decision that hurts your business. I mean, you're hurting your employees, your stakeholders, whatever. It's hurting your business. It's another problem when you're making a decision based on bad data and you're not giving somebody a credit card or not giving somebody a job. Right. So from that perspective, and I think that's what's been pushing a lot of the innovation in the ML ops world, because when you talk to organizations, it's one type of pain that they feel when their model fails and their manager is unhappy, right? It's another type of pain that they feel when the model fails and New York Times writes about how biased the model is. So I think from that perspective, ML ops space is really exciting, and I hope that this kind of ethical awareness of how bad data can impact our life is going to drive that cultural awareness. And once the cultural awareness is there, the ML ops community is going to be ready with the tools that we're building to make it actually a repeatable process and a transparent process.
Couldn't have said it better myself. So it's awesome. Cool. I think it might be a good place to sort of cap off too. For people that want to learn more about you and YLabs and the fantastic work you're doing there, how would they find out more?
Sure. Good place to start is on our website, YLabs.ai. The platform we're building, the observability platform, is available as a sandbox on the website, so anybody can log in and play around with it. In addition, another good place to be involved is in our open source efforts. So we're vending an open source set of open source libraries called YLogs, which enable data logging and data testing for both unstructured and structured data. So essentially, there is no more an excuse to not be logging and testing your data. It's all available on GitHub, and with just a simple pip install and a few lines of code. Anybody, whether they're doing machine learning or not, can start logging and testing and monitoring their data. So GitHub, search for YLogs, and their links also are available on our website, ylabs.ai.
Awesome. Cool. Well, thanks. It was a pleasure talking to you, and hopefully we can do it again soon. So, yeah, we'll cap off there, and we'll talk to you next time. So.
Fantastic. Right. Thank you, Joe.
Yeah, of course.